Welcome back to our third and final Camtasia session on aggregate operations planning. We are going to move away from Deb and her problem and talk about refrigerators for a while. Again, refrigerators are a nice mass-produced product. It's pretty much standardized, and therefore you probably make things in advance for customers that are going to show up down the road. You need some sort of forecast. Here's the information we have for the next 6 months. This is unlike Deb's problem. She had the next 4 quarters. We have the next 6 months. So when we come up to figuring out the level of demand and finding the average requirement, we're not going to divide by 4. We're going to divide by 6 up in here. This information is on Canvas. Under step 5, there's another link that will go and give you this. We're going to switch back and forth from this data to the spreadsheet, which is the link below the data that I just pointed out. Let's take a look at the data that we're given. Looks pretty much the same as what Deb had, right? We've got a holding cost up here. We've got a regular time labor rate. We've got a hiring cost. We got a layoff cost, and we got a shortage or a back order cost. We have a couple others, but we're not going to use them. Here's a subcontracting cost because, I mean, how do you deliver the products? You might just use your regular time. You might also use something called overtime. And so there's an option here. You could also have somebody else do it for you, in which case that would probably be called subcontracting. But if you scroll down to the bottom here, Plan A and Plan B are just like Deb's problem. Plan A said vary the workforce so that you meet demand, do not use overtime. And here's 8 employees on staff in December, because we're going to start off with January, but we need that. How many people did we start before? Here's Plan B, use a level strategy. Again, very similar to Plan B. Part C is the same. Which plan is best and why? We're looking at probably lowest cost. There's other things to consider, but we start with lowest cost. So, some more information. Here's the beginning inventory. So this is different from before. Now we do have beginning inventory. You don't worry about that. Here's the labor hours per refrigerator. So these 3 things are different from what we did for Deb. Okay. Now we don't have a hiring cost per unit. We have a hiring cost per worker. So we need to know how many workers we need for each and every month. Part of that is how much does a worker produce for you? Well, they tell us what the labor hours are per refrigerator. It takes 4 hours to make one. Okay. Now we're working an 8-hour day, so I would guess that each person makes 2 refrigerators in a day, and they work 20 days in a month. So each person makes 20 times 2, or 40 refrigerators in a day. Given that we start off with 8 of them, 8 people producing 40 in a month, sounds like about 320 refrigerators in a month right now. Okay, so that piece of information we're going to need when we go to see the Excel spreadsheet. So let's click on that. So here's the Excel spreadsheet. We're going to make it a little bit bigger. So meet the demand. So this is the chase strategy, right? This is part A. Meet the demand. By using a chase strategy, produce only what's needed to satisfy the customer. So here's a bunch of answers which we are going to quickly delete. So, and you never saw any of that information, and me neither. This information in here was given to us on that data sheet. That information was given, so was that, so was that. Okay, this information down here was given. We have already talked about this, 40 units per month per each worker. That's where it came from. Each worker is paid $12 an hour. And so we're working 8 hours a day, 20 days a month, so that will give us how much each worker gets paid a month. We're going to need that for labor cost. Here's the workforce at the end of December, ending inventory for previous month, 250 units. Okay, sounds like a done deal. We're not going to complete this problem because we've already done some of these. Again, you have the answers, so you can take a look at the answers and take care of that. So for January, we have here a demand of 1050. We're using a chase strategy. Okay, chase says meet the demand, so let's go ahead and make 1050. Wait a minute, I already have 250 sitting in inventory, so I don't think I need to make 1050. I need to make 250 less than that, or about 800 units. Okay, so that's just a little bell and whistle, but you know, if you got an inventory why would you make all of 1050? Why not use up your inventory and get rid of them? Okay, so that's what we're going to do every time we have an ending inventory for a chase strategy. Because a chase strategy says make what you need. I don't need 1050, I need 800. Once you get rid of the inventory, all the other numbers are the same. Well, that was good. Okay, ending inventory, once you get rid of that 250, bunch of zeros. Inventory backorder cost, none. I mean, if I had a positive number there, I'd be multiplying by 8. If I had a negative number, that meant I was backordered, I would take the number, multiply by 50, not the negative number. Workers required, let's do that one. Okay, because before we had 320 units being produced. How many workers did that take? 320 divided by 40, the 40 coming from down here. Now I need 800, so I take 800 divided by 40, that sounds like about 20. There's 10, there's 30, there's 5, 5, and 20. Now you can see that our required workers go all over the place, so we're going to have a lot of hiring and firing people, and we have a lot of hiring and firing cost. And notice I just got one column here for hiring and firing before we had two. It's because it's still pretty easy to do that, right? There's a minus 12, there's a minus 10. If the number's negative, make sure you use the 80. So this would be 80 times 10 or 800. The first number is 12 times 40 or 480. Okay. I'll let you do the rest. It would be good practice for you. And you already have the answer. So I'm going to move on to level strategy. Get rid of all this data. Okay. Same information. There's my information about that. Here's my 40 units per day. Nothing has changed. There's my 320, the 250, the 8 before. What has changed is the use of this word level. So we're going to use this thing back here one more time. Production is set equal to the average requirement over the 8-month period. Wait a minute, we don't have 8, we have 6. So let's change this to 6. And so then we're going to add up those numbers and then we're going to divide by 6. Okay? Again, if you had 8 months, you'd be using 8, whatever. What the formula says is take the total demand, add up all those numbers from here to there. But before you do anything called take the average, subtract out your beginning inventory. So this formula right here is equal to the sum of these numbers and then, whoops, and I'm going to subtract out this number and then I'm going to divide by 6. Now probably most of you realize that number wasn't right because I didn't have enough brackets in there. I need another bracket here. I'm going to sum up those numbers, then take out the inventory, and then divide by 6. I should have about 600 sitting right there. Okay? That's the only bell and whistle. Well, that's how the input data changes from chase to level. And it will always happen. We saw that happen in Debs, and then we're seeing it here. So that means that each and every month you need 600. That's how many you're planning on producing. Again, at the end of the 6 months, you better have 0 sitting right here. So the challenge might be to make sure that works out. So here's your ending inventory. Again, going back to Deb's problem, ending inventory equals beginning inventory plus what you produced minus what you sold. So in here, ending inventory is 250 plus production of 600 is 850 minus 1050, so minus 200. If you didn't figure that one out, go back and do it again. You could also put in a cell formula for this, equals the beginning inventory plus what I made this month minus what I sold. In other words, minus 200 plus 600. In other words, of the 600 I'm making in the month of February, 200 are going to take care of that customer. The other 400 are going to take care of these customers. At this point, I bet I could click and drag. And you notice I end up at 0 at the end. Okay? Again, feel free to rewind this, go back to where you want. You can probably see some cell forms in here that could help you make your spreadsheet so it's a little bit more automated. But it's also pretty easy to do this one step at a time, right? Ending inventory equals beginning inventory plus production minus demand. Okay? I'm not going to do all the other stuff because you can figure out the backorder cost. Again, you got the guides. Let's do one more on workers required. Okay, each worker makes 400 units in a month, and this month I need to make 600. So how many workers do I need? 600 divided by 40 equals about 15 workers, and so that number will be the same all the way down. Last step, compare the cost, and now we do have here a lot of dissatisfied customers, right? So even if this one turned out to be the lowest total cost, because we have so many dissatisfied customers in January through April, maybe this would not be the best answer even if it had the lowest cost. Flipping back to the chase. Think about what you don't have any dissatisfied customers, you're taking care of all of them. Look what you're doing to your workers, right? You're expanding like crazy. In the next month, you're cutting half those people. The next month, you're tripling your workforce. And the next month, you're laying off almost all of them. You want to be working for this company? If this company requires quality, they're probably not getting it from their employees because they don't know if they have a job next month or not. Probably not the best thing to do. Again, even if this might have the lowest total cost, this might not be the best answer for you. So that's sort of the type of discussion and arguments that need to be done as to which one is best. Okay? We are looking at primarily lowest total cost, but there are other answers to this too. Okay, I'm going to leave you there. Here's two more for you. Well, one more problem. Here's the chase problem. Here's all this data. Again, go back here, wipe out that data, and see if you can reproduce what's there based on these different things. Again, it's another 100 units per worker, so there's 1,600 workers there. 1,600 divided by 100 means you need 16 workers. Once you